Okay, we're starting with the first example of Unit 4.6. In Unit 4.6, we're going to do operations with complex numbers. Before even attempting this, you should have read pages 275 and 276 of your book, which is available in PDF format on the website. Now, as solving any other type of equations, we are solving this quadratic equation. We want to get rid of what? Everything that is with the x, because solving is to isolate the x. Now the first thing that we notice, since we're doing opposite order of operations because we are solving for x, we want to eliminate that 15. To eliminate that 15, we do the opposite process. The opposite process of addition is subtraction, and as it's already written here, all we would have to do is subtract by 15. If I subtract by 15 both sides, I'm going to have 2x squared equals negative 50. Now, if you notice, this 2 is multiplying the x. The opposite process of multiplication is division, so we should divide each side by 2. Now, what do I have left? I have x squared equals negative 25. Now, because it's an x squared, we have to take square roots to both sides of the equation, and I'm going to be left with x squared equals negative square root of negative 25. Now, since we already saw in 4.5 properties of square roots, we know that square root of negative 25 is the same as square root of negative 1 times square root of 25. I know that square root of negative 1 is I, and I know that square root of 25 is 5. So what am I going to have left? When I take square roots to both sides, I'm going to have left with x equals plus or minus square root of negative 25. And when I simplify that, I have that x is going to be equal plus or minus 5i. So my two solutions are 5i and negative 5i. Now here you have this first example. You should try and do it by yourself. I'll give you some time so you try it. If you have any questions or problem solving, your solution for this problem should be the following. So just as the example above, the first thing we do is get rid of the 13. Since it's adding, we subtract both sides. We're going to have 3x squared equals negative 36. Then I solve by dividing by 3 both sides, so it's going to give me x squared equals negative 12. I take square roots to both sides, so I'm going to have x equals plus or minus square root of negative 12. But then we go back again. What is square root of negative 12? Well, square root of negative 12 is nothing more than what? Well, if you remember the prime factorization method, I notice that's what? I have two factors repeated, so this is going to be what? 2 square root of 3i. When I simplify it, that's square root of negative 12. So I'm going to have that x and 1 is going to be 2 square root of 3i, and x2 is going to be negative 2 square root of 3i. This concludes the first examples of this 4.6.